Hi everyone. Today we can see about the recursive reason parser. Okay. So what is this recursive reason parser? So here the recursive reason parser means it is a top-down parsing technique, and the tree will be constructed from the top, that is from the root node to the leaves. Okay, that is why that is called a top-down parsing. Okay, and the input will be read from the left to right direction. Okay, so here in this recursive reason parser, it can produces a parse tray by using the method backtracking or without using a backtracking also. Okay, so next, the if the grammar, the only thing is that the grammar that is given to the recursive reason parser should not have any recursion. That is, if there is some left recursion inside the grammar, so we need to remove all the left recursion as well as the common prefixes. That is, it should be left factored. Okay, only then the particular grammar can be passed by the recursive reason parser. Okay, so here there is a form of recursive reason parser that does not require any type of backtracking, and that is known as a predictive parsing. Okay, so the parser which does not requires the backtracking is called a predictive parsing. So here this is the main step, that is the recursive. Why it is called recursive? So in order to when we implement this type of parser, we need to write a procedure or a function for each non-terminal. Okay. So here the procedures written in this particular recursive reason parser will be a recursive function. Okay, so we can see later slides. That is how we can write the recursive functions for each non-terminal which is given in a grammar. Okay, it is a context-free grammar. Okay, so first we have to, in order to, that is, we have to eliminate all the left recursion, and it should be a left factored grammar. That is, we have to remove all the common prefixes from the grammar. Okay, so here this is an example that shows a removal of the left recursion. So given three productions are there, and we have three different non-terminals, capital E, capital T, and capital F are there. Okay, here this is a left recursion, that is okay, we need to apply the rule for respective rules for removing the left recursion. Okay, so I'm not discussing the removal of how we can remove the left recursion. Already we have seen that. Okay, so here this is the rule. Actually, this is the main rule used for removal of the left recursion. Okay. So when we see what are the disadvantages and limitations or the advantages of this type of parse, that is, here there is a recursive reason parser has to have a appropriate form of grammar. That is, it will only parse the grammar which does not have any type of recursion or any type of common prefixes. Okay, so after removal of all these ambiguities only then our parser will parse through this particular grammar, and it will generate the corresponding parse trees. Okay, so here in order to implement this recursive reason parser, we need to have a stack, and this stack has to be called for each variable for each variable comparisons, or the all each the input string comparisons. We need to perform the stack call actions. Okay, so again, these are some of the recursive procedure calls we need to implement the which has to be implemented using the stack. Okay, so it is very difficult to automate. So these are some of the limitations of recursive reason parser. Now we can see how we can design a recursive reason parser. Okay, so this is how. So here these are the prerequisite. That is, the grammar should not be left recursive, and it should not have any common prefixes for alternates. That is, the grammar must be left factored. Okay, so how you can design that? That is, we need to write a procedure for each non-terminal which is given in a grammar. Okay, and the procedure does not return anything. Okay, only and we need, if suppose there are more than one production for a single non-terminal, and we need to include all these productions. Production should be written inside this particular procedures. Okay, and if suppose there is a failure, then we have to call a error routine, and which will take care of the particular error. Okay, so we can consider an example. Here we are given we are asked to design a RDP, that is a recursive design parser, for the input string I plus I and a dollar symbol is there. That is, the string will be end by using a dollar symbol. As we are using a stack as a data structure, a stack data structure is used here. So here, in order to know the end of the string, we can use a dollar symbol. Okay, and we are given a grammar. Okay, this is a grammar given, that is E gives E plus I or I. Okay, so here this is a left recursive grammar. We can remove the left recursion by using the rule, and we will get these two productions after removal of the left recursion. Okay, this is here. That is E gives I E prime, and E prime gives plus I E prime, or E is a epsilon. Okay, so what do we have to do? That is, we have to write a procedure or a function for each of the non-terminal. Okay, so here I'm using just an abstraction of a C programming language is used here to represent the procedure. Okay, so here I have to define these are E and E prime are the two different non-terminals used here, given in this particular grammar. So I have to write, or I have to define E and E prime. Okay. So what is this E prime? So E prime, sorry, first we have to discuss about E. Okay. So this is the procedure for which is written for the non-terminal E. So here the E will be a function. Okay. Then the first symbol is I, right? And we need to compare. So here this is a variable that is called a input variable. Okay, so this variable is used in order to move the pointer. This is a pointer which is pointing to the first symbol of the stack, and as soon as we have matched this thing with our input string, then this pointer will be moved forward. Okay, so here there are three conditions need to be checked. That is, suppose if the input given in a string, input string is a non-terminal, that is, if suppose it is a capital letters or something like that, then we have to call the particular procedures of that particular non-terminal. Okay. Then second thing is, if it is a terminal, that is small letters or something like that, or the identifiers, then we have to compare this terminal with our input string. Okay, and we need to check for the if there is if these two things are same thing. Okay, if they are same, then we need to increment this input pointer. Okay, only if there is a match occurs, then only we will increment this input pointer. Okay, so here in this case, we are checking that the first symbol is a identifier I. Okay, so here now which is a terminal. Okay, so here we are checking that is input is equal to I. Okay, if there is a match occurs, then we can increment the input pointer. Then what is that other thing? The next symbol is a non-terminal E prime. So I have to call the second function, that is E prime. So I am writing this function name as E prime. Okay. So here there is a call to the next function, that is E prime from here. So here we need to call the function, that is E prime. So here this is the corresponding production for E prime. Here E prime gives plus E plus I E prime or epsilon, right? So here the first symbol is plus. So the input pointer should check whether the first symbol is a plus symbol. Then if it is a plus symbol, if there's a match occurs, then we need that the input pointer will be incremented. Okay, so next it will be pointing to the second symbol, that is a I. So again also the input pointer will check whether it is a I. Okay, if there's a match occurs, then the pointer will be incremented to the next location. That is, the pointer will be moved to the next location. And next symbol is a non-terminal, that is again E prime. That means here there is a recursive call. A function is calling itself. But here only we will say that it is a recursive call, that is a function calling itself. Okay, so again it can be called and the same steps can be repeated. Okay, then otherwise, so second thing is that if this particular production, or we can have an epsilon, right? So in order to implement the epsilon, we can have the else part, that is else you can return nothing. Okay, just returning to the main function. Okay, is that, I hope it is clear. So next we can have the next so here the recursive descent parser will write one function for every variable. That is we need to write a function for every non-terminals. Okay, so here it is not necessary to write the main function or to declare the variables and all. Okay, so it is not important to write the main function. If we are writing a main function, what we have to do, the we have to call the start symbol of this particular grammar in from the main. Okay, and next, okay, the first statement should be the call to the start symbol. Then only the start symbol, that is here, if you consider this grammar, here the start symbol is S. So if you are writing a program, so I have written a main. So the inside the main, the first statement should be the function call to the start symbol. Here the start symbol is E. Okay. Next, when this function is invoked, then the control will be given to this particular this function. Again, inside this function, there is a call to E prime. Then everything E prime will be recursively processed. Then after after attaining the epsilon only, the control will be given back to the E prime. Again, it will go to this thing and this function will end. Then after that, the control will be given to the main program. Okay. So after executing all the functions in E and E prime, the input pointer will be pointing to the dollar symbol, which is the end of the string. So now we need to check whether the input currently the input is pointing to the dollar symbol. If so, then we can say that the parsing is done successfully. Okay. I hope it is clear. Now we can consider an example. That is, I'm here. Considering an example, that is I plus I with the dollar symbol. Okay. So here, what is this I? So initially, sorry. So this is the I, and I am having the. Okay, so first we need to start with the main program. Here we have a function called it to uh, E, right? So here, what is this E? Okay, so now we are considering the input, that is I plus I, and we are ending it with a dollar sign. Okay, so here, initially the control is given, starts from the main program. Okay, the main program will call the function E. So first we will check whether this input is equal to I. So here the input string first symbol is I, right? So the match occurs. Currently the point is pointing to this thing, and we since it is a match, then the pointer will be moved to the second location. Okay. Next, we have the function called to E prime. So again, there is a e prime function call will be there. Then again, we will check for a match, that is input is equal to plus symbol, right? So here currently this point is pointing to plus. Again, there is a match is there. Therefore, we can move the pointer to the next location. So here I am moving to the third location. Okay. Then again also there is a pointer, that is if input is equal to I. So here also the input pointer is pointing to I. We are checking for I. So there also a match occurs. Now I am incrementing my pointer to this location. Again I am calling the E prime. So here again I am calling the E prime. Now I am checking whether my input is equal pointing to plus. Now, but currently my input is pointing to the dollar symbol, right? So this test fails. So I will go to the else case and I will return my function. Again, my control will be given to this particular function where it is called. Okay, since this is the end of this function, again it will be moved to the main function. Okay, here in main function, what we are checking in main function, we are doing a so in main we are checking whether after coming back, after all the procedures it will reach here, we are checking whether the input is equal to, that is a dollar symbol. Currently my pointer input pointer is pointing to dollar itself. Therefore we can say that it is successfully passed. Okay, this is how you can design a grammar, design a parser, recursive design parser for a given grammar. Okay, I hope it is clear.